Hi everyone. We are now moving to the bottom half of our yellow sheets, the formula sheet. So we've been working entirely on the top half when we're dealing with proportions. Proportions are with categorical data, so things like smoker, non-smoker, what's the percent of smokers? Employed, unemployed, what's the percent of employed? Now we're moving to the bottom half where we're dealing with means, so average height, average weight, that sort of thing. So what we're doing is very similar to what we did before, only we're using a different kind of data, quantitative instead of categorical. So we will be doing t-tests instead of z-tests when we're working with means instead of percents. So z-tests work with percents, t-tests work with means, but it's very similar. We're going to start out with one sample. We'll be doing confidence intervals, where we're trying to estimate the population parameter, the truth in the population. So before, when we were using z-tests, we tried to estimate the percent of the whole population, say, that has been exposed to the coronavirus. Now we're trying to estimate the mean height of the entire population. We'll be doing hypothesis testing, whereas before we would test a hypothesis like half of the population in the country has been exposed to the coronavirus. Now we're making a claim about a mean. The average age of 5th graders is 10. And then we'll switch to two samples. Before we did a confidence interval for the difference in percents, like what's the difference in the percent of people in California versus Michigan who have been exposed to the coronavirus. The confidence interval gives us the size of the difference. How much higher is the percent in California than in Michigan? And hypothesis testing, is there a difference? Is there a difference between the percent in California exposed to the coronavirus versus the percent in Michigan exposed to the coronavirus? Is there a difference? Now we'll be dealing with means. What's the average difference in height between people of Dutch descent and people of German descent, whatever, okay? So two groups, how big is the difference in average height between those two groups? And then hypothesis testing, is there a difference? Is there a difference? So very similar to what we've done before, only now we're dealing with means instead of percents. We have a few assumptions for the t-test. The first one is the same as for the z-test. We assume that our sample is random, so a simple random sample. And the reason, of course, is that we need our sample to be representative of the population in order to draw any correct conclusions about the population. So choosing a sample at random reduces bias. It makes it more likely that our sample is like the population. We also assume that the observations are independent of each other, that there's no matching or pairing or anything like that, that it's not like a bunch of people came from the same family. But if we're choosing people at random, they're probably independent of each other. Now we have a new assumption, and that is that our quantitative variable has a normal distribution. So with categorical data, we never had to worry about the normal distribution because we just had groups, categories. But now we have a quantitative variable like height, or age. And so we're assuming that that quantitative variable, height, age, has a normal distribution, that bell-shaped curve, and no outliers. The question is, may we break any of those assumptions and use the t-test anyway? Well, we may not break the assumption that our sample is representative of the population, that we have a random sample. So we may not break that one. We also may not break the assumption that we have no outliers, because outliers have such a big effect on the mean and the standard deviation. The one assumption we may break is that our quantitative variable has a normal distribution. We may break that if our sample size is big enough. So what's big enough? Well, a sample size of 40 is surely big enough. If it's very skewed, we may use the t-test anyway if we have a sample size of at least 40. In fact, we may go down as low as 15 if we have a slight skew in the data, but below that it should look very normal. So t-tests deal with means instead of percents. Our assumptions are simple random sample, independent observations, and that our quantitative variable has a normal distribution with no outliers. Of those assumptions, the only one we may break is the normal distribution assumption, and that's if our sample size is big enough. So the next 3 videos we'll talk about confidence interval for one mean, sample size if we're trying to figure out what a mean is, and hypothesis testing for one mean.